Right then, I think we'll just get started. So thanks very much, guys, for taking the time to join the webinar this morning. This is the last one in the series of webinars that we've been doing, specifically on Fusion 360. So the recordings will be available after. If anyone wants to get access, then you can email me directly, or they should be available on the website. There should be a link on the website to get access to previous sessions, webinars that we've done. So today we're going to focus on CAM. It's just going to be a quick overview of CAM in terms of we're going to do some 2D and 3D features. We'll look at the post-processor within Fusion 360. And we'll look at some other examples of what Fusion 360 can provide for you in terms of CAM, but we're not going to go into the nitty-gritty details. If anybody's got any questions, I would just say, can you keep it to the end of the session, please? It's just Wazim's not on the call today, so I don't have my buddy with me today, so he's actually on another call. So if you've got any questions, if we keep them to the end, it just means that it makes it easier for me to answer, so that you don't think I'm ignoring you. All right, so let's get started, guys. So like I say, we're going to begin over Fusion CAM. Again, just to give you a bit of knowledge about Symetri, this is our motto: we challenge people to work smarter for a better future. So we're going to have a look at the benefits of using CAD CAM. So Autodesk provide a few different packages that will allow you to use CAD and CAM together. So if you've got access to the product design and manufacturing collection, at the moment you've actually got access to HSM, or this year's version is called Inventor CAM, which is 2020 version, or you've got Fusion 360. We're going to focus on Fusion 360, but just to make you aware that the tools in HSM and the tools in Fusion 360 are almost identical. They are bringing some of the new tools into Fusion 360 from other packages that Autodesk provide that are not in the product design suite collection, but we can look at that later on whenever we look into Fusion 360. So some of the benefits, guys, of using CAD CAM are eliminating data translation issues. So when you've created your CAD model, how do you get it into the CAM? Model association is a must-have at times. You want to be able to change your model, and you want the CAM to update as well. Simplified workflows, automating more of the manufacturing process, full design functions, integrated validation of your tools. Keep them organised and working within a team. So you could have a team that focuses specifically on the CAD and one that focuses specifically on the CAM, and you can share that data, sharing knowledge between departments, and also the cloud functionality, so having it stored within the cloud, and also being able to share it with maybe people that are not in your organisation. Okay, so that's some of the benefits of using CAD CAM. So like I mentioned earlier, today we're going to focus on specifically how we start up a new job, some 2D machining features, some 3D machining features, toolpath simulations. Obviously we simulate as we go, and then from there we're going to look at some post-processing code, not in too much detail, but just basically how you generate the code. All right, so let's just jump in to Fusion and have a quick look. So if anybody's not actually aware of the tutorials and the help files for Fusion in general, what I would advise you to do is have a look in your data panel. Right at the bottom of your data panel, everyone should have access to these folders. So within your sample folders, you've got access to CAM samples. And this folder is really very good. There's lots of different tools within here. You can see how it narrows it down to 2.5D. You've got 3+2, 4 axes. Lots of different examples that you can go in, copy into your own folder, and make changes and mess around and basically challenge yourself. to start using the CAM tools within Fusion 360. So make yourself aware with that, of that, and there's also basic training for other functions. So obviously with the Fusion CAM side of stuff, you do need to have the product inside the CAM functionality. So if you've got any specific CAD queries as well, or you're wanting to model something specifically, then the basic training folder there will help you as well. Okay, so I'm just going to go back up into my Fusion folder. So this is the example we're going to start off with, guys. We're going to do, like I say, we're going to do some 2D machining features first of all, and then we're going to move over to some more advanced 3D features. The other thing I would make you aware of is there might be some terminology within this webinar that you might not understand. To be honest with you, the CAM side of stuff is a bit crazy because people call things features within CAM could possibly be slightly different. So if you've never done any CAM before, you can also brush up in the terminology. I had to brush up in my terminology, to be honest, when I started using CAM a while back. So I apologise if there's anything you don't understand, but like I say, it's a learning curve for everybody. So we're going to jump from the design side of stuff. Just to make you aware, guys, I've got the most up-to-date Fusion 360. So any buttons that you don't see, then make sure you've got a fully up-to-date version, because we've got a few different tools that have been added into Fusion in the last couple of weeks. So just make sure you've updated. So what you'll notice is the model environment is called the design workspace, and the workspace that we're going to use for manufacturing, which used to be called CAM, is now called manufacturing workspace. So if you make sure you've got the up-to-date version, it means that then when you look back in this video, you'll be looking back and you'll be able to pick the right things from the right menu and things. Okay, so we're going to move to the manufacturing workspace just now. I'm going to get rid of my data panel so you can see the full screen. So like most of the Inventor platforms, we work from the left to the right, and you'll see that there's lots of different tools within the manufacturing workspace. So what we tend to do is we start with a setup, and that setup could be a mixture of 2D and 3D, or all 2D and then 3D, or it could be multi-axis. And then when you're doing turning, you can do setups specifically for certain areas of the part. So we're going to specifically work on just one setup at the moment, and then the example we look at later will look at more than one setup. Okay, so when you select the setup, the first thing that you need to do is tell the system basically where you want that setup to be in terms of your coordinate system. So you can see just now it's all default, it pops up and it's giving you stock. So if I zoom in slightly, you can see the stock's just overhanging the part. So you've got different options within your setup. So keep an eye on the right hand of your screen just now, guys, because this is where we're going to focus a lot on the input that we're going to get to produce the tool paths on the screen. Okay, so you can see some of the setup here. This is a future new tool where you can actually pick the machine. So soon you'll be able to pick from a machine that could be on your manufacturing floor, but we're not going to go anywhere near that just now. We're going to stick with some of the basic stuff. So the setup type, milling is going to be the one that we're going to set up just now, and we're going to work with milling operations to start off with. But if you make yourself aware of the drop down lists in most of these tabs as you're working through, the best thing about Fusion 360 is the tooltips. I mean, look at how good this tooltip is just now, the operations it's telling you. A lot of the information that you see within CAM has these very good tooltips that will give you a heads up on what you're doing and when you're changing things, why you're changing it, things like that. So it's a confidence builder as well. It helps you to narrow down specific areas so that you know exactly you're adding things into the correct setup and then adding it into your code. Okay, so we're going to stick with milling just now. Next thing we're going to do is we're going to set up the coordinate system. So you can actually use the model coordinate system, or you can specify different criteria. So we're going to go for Z-axis. We're going to actually pick an edge of the part. So you can see it's either the stock or the part, but we can only select the part here just now. So we're going to highlight that edge in the side. So we're basically going to make sure that we're working in the positive X and the positive Y direction, and the Z is always up and down. Because if you imagine your machine tool comes down onto the part, it produces your cut and then rises back up off the part. So that's why we're doing the 2D features to begin with. Okay, so we're going to actually move this coordinate system to a specific point. And to do that, we're going to make sure it's on stock box point, and then we're going to go down and highlight the box point. And when we do that, it gives us points on the box that we can specify where we want the coordinate system to be whenever we are, if you imagine it, it's going to generate X and Y coordinates, X, Y and Z coordinates from that point. So we're going to specify this point here. So when we specify this point, the only thing we need to do is make sure it's picked up the whole body. And then we're going to move over from setup. So we're going to go from setup to stock. So when we click on stock, probably the most important thing in here is the mode that you select and also the offset of the stock. So before you start, you tend to know what the stock will look like in terms of, before you machine this part, you'll know how much stock you've got available and what size that stock is. So we can come in here and we can generate from the offset, basically if we want to add stock or no stock. So I'm going to specify no stock in this instance. It'll give you some dimensions about the size of the dimensions of the stock. We've also got a tab for post-processing, but we're just not going to go into that just now. We'll leave that till later on. So we've done our setup, we've got our stock, and we can click OK. So basically that gives us a setup now on our browser in the left-hand side. And then from there, in this setup, we can then add some 2D features. So when you drop the list down for 2D, basically again, because it's very good with tooltips, we can hover over any of these features and it will give us a quick explanation of what that feature basically does for us during the CAM operation. So this one here is basically how we finish off and prepare the top surface. So that's the thing we're going to start off with. We're going to start off with a face cut. So I'm going to click on face. And then this dialog box on the right hand side has been actually docked there specifically. If you prefer to move this, you can do. But what you'll find is the same processes must be taken through each of the different features. So you'll pick a tool, you'll go to geometry, you've got heights, passes, and then any linking. Okay, so we're going to start off with the tool to begin with. So when we pick up our face, we're going to pick a tool from the library. So if I pick on select just now, it's going to take us into an extensive library. So the good thing, another good thing about Fusion 360 is the library itself. So within the library, you've got tools that come in the samples folder. So you can go down and navigate down into each individual material, and you can pick whether it's metric or imperial, and you can pick and choose from any of the types of tool that are in there already. And when you start to use them, basically they'll become part of your document. So they'll become part of this list of the tools that are generated and used within your part. So the other thing that we can do is, just to make you aware, is we can create new tools. We can create new holders. We can create new cutters for turning as well. We can also create new plasma, laser and jet, water jet cutting as well. So if you're into that side of stuff, then you've got lots of different options in here, okay? These are the tools that I'm going to basically use for the setup. So I'm going to start off with a flat mill head, end mill. If I right click on this just now, just to edit, just to show you some of the basic default inputs that you have to make sure you've got with your tool. So you can duplicate the tools. So let's say, for instance, you've got a holder and you want to keep that holder and you want to change the tool. You can duplicate an existing one and change the dimensions of your tool in this dialog box. So you can see from the drop down list, you've got a heap of different types, and then you can narrow down all the information about this cutter. Okay, so you've got lots of information that you can narrow down within your library. It might actually take you a bit of time to get to the stage where you've got a lot, but you can also share them as well. Okay, so we're going to pick this as our tool just now. we're going to go over to geometry, and it will automatically pick the stock around the top, the face. So we're going to leave that default. We're not going to bother too much about the heights just now. We're going to go straight directly over to passes, and we're going to look at the passes just now. So I think the only thing that we're going to change in here really is just the step over. So let me just see actually. We'll change the step over. In fact, we'll leave the step over as is, and we'll change the pass extension. So just to give you a bit of knowledge, if I hover over it, actually you can see that the distance that extends over a boundary is basically that pass extension. So I'm going to change that to 10 just now. Okay, and I'm going to leave all the other settings as is, and I'm going to leave the linking settings as well. So basically, just to give you a bit of knowledge on the linking, the most important part here is basically the high feed rate mode, and this specifies when the rapid movement output is. So basically, we tend to work in this example with all the rapid movements preserved. Okay, so we're not going to change a lot of the details in that tab. All right, so if we click OK, the system will go away and it will generate that first face cut for us. And you can see now it's actually providing some lines on the screen that we can zoom in and we can see how it's actually interacting with our part. So just to give you a bit of an explanation on the colours that you can see of the lines, so anything that's yellow is a rapid movement, anything that's green is lead in or lead out, anything that's red is ramping movement. So we don't have any ramping movement on this because it's a face movement, it's a face cut, sorry. And then the blue is basically anything that it cuts, any material that it cuts away. Okay, so as you produce different features, you can then simulate up and see what it looks like after it's cut your stock. So you can either right click on the part, the feature, sorry, in the model browser and go down and simulate from here. You've also got actions up here where you can simulate. If you want to simulate a full setup, you must select the setup and simulate. But we're just going to simulate this one just now. So if I click on simulate, you get all the simulate tools at the bottom of the screen in the middle, just down here, which is really good. And then if we press play on that one, we can actually change the speed. We can speed it up and then we can slow it down. Obviously, if there's intricate bits of your part and you want to see exactly how the tool is producing within that small area, which we'll see in a minute, you might want to zoom in, which you can do as you play the simulation. So we can zoom into specific areas and we can see exactly how it's cut, right? So we could also change the simulation look, so we can actually see the toolpath if we want. So we can untick and tick the toolpath on the right hand side. We can also decide whether we want to see stock or we don't want to see stock. Most of the time you will want to see the stock. I usually tend to keep the toolpath off and focus more on the stock so that I can see exactly what it's doing. More information about the position, the operation. If you have chosen a machine, it will give you information about that. And then probably the most important thing is the statistics, and that will tell you the time it takes to run that operation. Okay, so it's very important that you can tell what time it takes. All right, so we're going to move on quite quickly and we're going to start doing another couple of different features within the 2D drop-down list. So we're going to go and use a pocket this time. So the pocket's going to be used basically to remove the material within these two pockets. All right, so what we're going to do is we'll just leave the tool as is. We're not going to select a different tool. We're going to move over to geometry, and this time we're going to pick the bottom edge of that first pocket and then the bottom edge of this second pocket as well. So what we can do in here is you'll notice there's two red arrows, and if I select them, you'll notice how the material, it basically pops in or out. So we need to make sure that obviously the material we're want to remove is inside of that edge. So we need to make sure the arrow is actually in that direction so that we can remove the material within. Doesn't make sense to move the material out. Okay, so just make sure the arrows are facing in the right direction. We're not going to focus too much on the height just now. We're going to move over to the passes and we're going to make some changes in here. So basically what we're going to do first of all is we're going to go down to the maximum step over and we're going to change this from 9.5 to, we'll just put 3 mil in there just now. So basically the maximum step over is the horizontal step over between passes. We're going to go down and also we've got stock to leave. So anything that what we tend to do is obviously we do roughing of the machine part first of all. We rough out as much material as we possibly can, and then we can go back and we leave some stock on and we do finishing, and we finish up the part obviously to make it. We can't, if we go in and decide to do everything all at the one time, we're not going to achieve that surface finish on our part that we need. So we need to leave some stock at times. So that's what this tick box at the bottom does. So it's going to leave stock either radially or axially. So we're going to change the axle to 0, and we're going to leave the radial just now. And then the other thing we want to do is, I'm going to move over to the linking just to make you aware of a few things in here. So basically, what we can do in here is we can also change the ramp. So in terms of how it ramps in and out. So if I just hover over that for a second, you can see there's different types of movement as it's cutting down into the depth of your part. So basically, you can pick and choose which one suits the type of cut that you're producing. In this instance, we're going to use helix quite a lot, which is this one at the bottom right one. If I just hover over that again. So the one at the bottom right is the helix. That's the one that we're going to use in this example. All right. So I'm not going to change anything else. I'm just going to say OK to that. It'll generate the tool paths, and again, it will add it to the left-hand side in the browser, and we can simulate that up. So if we go back to the beginning and simulate everything all at the one time, just so that we can see exactly what it's doing. We can see it's going to cut the face at the top, and then it's going to go through and cut these two as well. All right. So the next thing we're going to do is we're going to look at a different 2D feature. We're going to look at 2D contour this time, and we're basically going to use this feature here to finish the edge all the way around the part, and then do some finishing of the two pockets that we just did. So this time we're going to use a contour. So I'm going to pick the 2D contour this time. Again, I'm going to leave the same tool. I'm going to go over to geometry, and I'm going to pick the edge at the bottom, and then I'm going to pick the two edges at the bottom of the two pockets as well. We're just going to go for the whole thing as a loop. Okay, that's actually a nice wee feature that we just seen there. We can actually pick an edge or pick a full loop. Okay, so from here, we're then going to move over to the next tab, which is heights. We're not going to make any changes in there. We're going to go to passes, and within the passes, we're going to make a change. We're going to add multiple depths. So basically, we're adding some multiple depths because of the different depths that we're going to machine down to. So we're machining the outer profile, but we're also machining two different depths in the pass as well. So we're going to put multiple depths on, and we're going to change the multiple roughing, the maximum roughing step down to 3. Okay, and then we're going to move over to linking, and we're going to put ramping on, and we're going to leave the ramping defaults. All right. And we'll click on OK to that as well. Now go away and generate the path. So you can see the difference now on the red. So we're getting some red in this one, which if you remember, I mentioned earlier, the ramping movement is actually the red lines. The blue ones are the cut and green lead in and lead out, and the yellow ones are your rapid movement as well. Okay, so you can see how it's generated that as well. Okay, so that just gives you your 2D contour and finishes off the outside of the part and the two pockets as well. All right, so the next thing that we're going to look at is we're going to have a look at something called a 2D chamfer, but at the moment, if I just zoom in, I'll just show you that the model doesn't actually have a chamfer on the edge. But the good thing about it is we can actually add a chamfer into the code, so we can tell the system that we want a chamfer on that edge, even if it's not modelled. So we can go up and pick from the 2D drop-down list and select 2D chamfer. Then we're going to go and select a different tool this time. And basically we're going to go for something that's got that chamfer mill. So I'm going to go for this chamfer mill tool that I've specified earlier. And I'm going to go over to geometry, and I'm going to pick that top edge there. So basically what it's going to do is it's going to run around the top edge, and it's going to cut away a chamfer for me. And the chamfer distance is basically going to be specified on the passes. So if we go into passes, you can tell here from the chamfer, basically the chamfer width, offset, and any clearance that we want to put in as well. So we're going to leave that as default just so that you can see it doing it. We're not going to change any of the default options in linking. We'll just click on OK there. It will generate the path and run around, and it will create the chamfer. So I'll just simulate that up just now so you can see basically how far we've got with the simulation. Just speed it up a wee bit so you can see. And then it's cut. You can see if I zoom in on that area there, you can see it's going to cut that away. You can still see the model. Again, you can go back to the model at any stage and make any changes. So if I just close that just now, for instance, if I want to go back and make a change to the model, let's say, for instance, we're going to change this pocket that we've just cut. So we can go back here and we can basically go back into design. And from here, we can go and find the direct modeling tool. I'm going to pick that face in there. And I'm going to say, right, okay, well, let's just cancel that. Sorry, picked the wrong one. We're just going to say, right, okay, well, we want to make that a bit bigger. So we're going to take it up to like 35.5 maybe. And then just say okay to that. So what will happen is after we've made that design change, and this is really important obviously to using the CAD CAM functionality, when we go back to manufacture, the only downside is obviously if you've got a lot of setup and you've made one change, you have to then go back and regenerate each of the toolpaths. But it doesn't take long to do this. So what we can do is we can generate from the actions drop down list, and we can also generate from here. So if I click on generate, it will go through each of the different features that we added and regenerate the code. So basically the code that was created, the XY coordinates all have changed because we made a change to the model. And that's obviously the most important thing about using CAD CAM. So being able to change the model and update the CAM output. All right. So from here, we're going to do a couple of drill features. But what I think we'll do is just to show you that, let's say for instance you want to cut out these two holes as well here. We're just going to use a pocket feature for these just now. But you might have wanted to put the pocket feature after this one. But we can actually do it just now, and then we're going to move it up the browser. So we're going to go back into pocket. I'm going to just change and select my tool. So I'm going to pick my flatten mill tool, and then I'm going to go and pick the geometry. So I'm going to pick the faces in here. Oops. Okay, so once we've done that, we've picked a geometry. We're going to look at the heights just now. That should be fine. We'll go passes, and let's change everything else. Just leave that as is. Say okay to that. So let's say for instance we want to edit that. So after we've done it, obviously it's not going all the way down to the bottom of the part. So we want to edit that feature. So I'm going to go in and say edit. I'm going to go back to the heights, and I'm going to change the bottom height here to the model bottom. And then I'm going to change it so that it comes out the bottom and doesn't leave any material at the bottom. Obviously, if there was fixtures attached to this part, you would make sure there was enough clearance, and you wouldn't drill all the way right down into your fixture. Okay, so we are not working with fixtures just now. We're just working with the tools. I'm going to say okay to that. It'll go ahead and generate the pass again, and you'll see this time it's put the cut in. So if I simulate that up at the moment, just to show you quickly. All right. So what we possibly could have done is we could move that pocket up to be the process after that one. So all very much depends on how what machine we're using, if it's capable of doing certain things. Do you know, all of this is obviously something we need to think about before we start to use certain functions within Fusion 360, because Fusion 360 is capable of lots of different things. So it's really important that you make sure that your machine is capable of doing certain things before you overpower the machine. There is something we haven't really spoke about much, and that's feeds and speeds. We tend to make sure that you make yourself aware of the types of feeds and speeds and the machine capability before you plug in any information, and obviously and push the code out to a machine. So it's important that you take various different steps and keep yourself safe whenever you're using CAM tools. I'm pretty sure most of you know some guy who's just fabulous on the machine, and will be able to help you out. So the next thing we're going to look at, guys, is just some drilling. So I'm going to go and pick a drill tool. What I'm basically going to do is I'm going to spot face for these two holes, and then I'm going to drill through the holes. So I'm going to change the tool first of all. I'm going to pick my spot drill, and the good thing about, one of the best things about drilling holes within Fusion 360 is the fact that when you pick the inside of one of the holes, you can tick this box here which says pick anything that's the same diameter, and then it will add that to the code as well. Okay, so when we move over again, we're going to move over to heights, and we're going to look at the heights. So basically what you can see just now is we have basically created the geometry. We've picked the geometry and everything for this one. We've picked the faces, and it's drilling in terms of it's going all the way down to the bottom. But what we don't want it to do is we want it to just spot face. So we're going to go into the heights, and we're going to basically change this from to a selection, and we're going to pick the top face. And then at the bottom here, we're going to say at the bottom of the cut, basically, we're going to change that to top height. And then we're going to make this a minus figure, so -1. So it'll come down, if you imagine that's where the slot exists, it's going to come down past the slot. And then the next thing we're going to do is we're going to make sure that we tick the box to drill tip through the bottom. In fact, we don't need to do that in this instance. We can do that in the drill, so we'll just leave that as is. Okay, so then it's going to, in fact, is it going to drill? Yeah, we probably want to be creating it from the face and the inside. That's fine. We'll leave it as is just now. All right. So the next thing we're going to do is we're going to look at the another drill function. So we're going to go up and pick on drilling. We're going to go drill. This time we're going to change it to our drill bit. And again, we're going to pick the geometry, which is the same as the last one. We're going to select the same faces. We can also duplicate these. So if I right click on them, we can duplicate them. So if you were going from spot face to drill, you could potentially duplicate it and it would keep the same selection. And the only thing you would need to change was the tool and possibly the heights. All right. So this time we're going to go into heights and we're going to look at it on the front so that we can see. As you can see, obviously it's coming through the part, but it's not coming right through the bottom. So we need to tell it at the bottom height that we want that to basically come through and drill to the whole bottom. So if we go whole bottom and we put in a -1, and then also we're going to tick this box here, which basically will tell the system and our code that we want to drill through the bottom of our part. All right, and if I say OK to that, you can see let's put that into our setup as well. Okay, so we'll just simulate setup just now, and we can see the differences. All right, so you can go back and simulate at any stage. I would advise you simulate as much as possible, because if there's a problem, you want to indicate the problem higher up before you do all your toolpaths and realize there's a problem, and then it could potentially affect other features that you place in. All right, so that's just looking at some of your 2D features. We're going to move over to another different example, guys, so that we can look at some 3D. I'm just looking at the time, so I'm going to keep this one quite brief and just show you. What I might do is actually just show you a couple of different examples. I'll show you the actual finished. Let's just see. This is the finished part. Let's just open up this one. So this is the actual part once it's finished. So the setup one is basically most of the setup one is some of the roughing, and we've used some of these tools here, which is adaptive clearing, if I hover over it for a second, you'll see the adaptive clearing and the pocket clearing are basically roughing strategies to allow you to try and get as much information, like as much material away in certain areas. So you can see this model is quite intricate in some of the small areas. If we move in, you can see there's lots of filleted corners and things like that. And we need to use some of these excellent tools that we've got that Fusion 360 provides us. Adaptive clearing is one of them, and pocket clearing as well is a very, very good tool. But we've also got so many different tools within the 3D features that help out so much. And this is what I was saying about the terminology. You might not be used to the terminology that's being used, but you will soon, get confidence with using the tools and why you're using them. So like I say, that setup one, this setup here is mostly roughing out, and then the second setup here is a lot of tools that will help you like get more of the material out of these small areas. And also, like if you look at this scallop, for instance, which is this feature here, this creates passes in constant distance from another, and it's offset inwards. And the reason why it's sticking to those main chamfers, fillets around the corner is, if I edit that just now to show you, it's actually a selection in terms of face. So when you pick the geometry, you can actually use tools like, you can tell it to avoid and touch faces. So this is a very good feature where you can say, only touch the faces that I've specified, and then you can also specify an offset. So an offset from that face, a clearance from where it's touching the part. So in this instance, that scallop will only touch that area around there, and then you can put in some sort of clearance distance from the selected surfaces as well. All right. So if I simulate this one up just to show you from the beginning, just make it a wee bit. So there's a lot going on in this one. So there's a lot of roughing out to begin with, a lot of the material disappearing quite quickly. And then a lot of it looks like it's not doing much, but what it is doing, it's actually starting to do the finishing features. So you can see it's going into setup 3 now, and it's finishing all that area. And you can see how the colours are changing, and it is removing the material, and it's finishing off the part, and it's going around all those fillets and making sure that it cuts away as much of the information, the material as it possibly can. All right. So just to show you another quick one before we get finished up. So this one here is, this is actually using a fiction. It's a very good example of using, within Fusion 360, you can actually use a pattern tool. So what you can see within this part is, this part here, this feature is actually duplicated, and it's actually symmetrical over the part. So the good thing about Fusion 360 is, within the tools, you can actually use a circular pattern, and you can say, right, okay, well, if you've already done the setup once, then make a pattern of that and set it up at the other end of the tool. So if we just simulate this up so that you can see, there's quite a lot going on in this one. If we just simulate it up, you can see how it's, well, that was a bit quick. Let's just slow that down and take it back a bit. Start again. That was really quick. Right, okay, so we can see that it's starting to do some of the adaptive clearance, taking the pockets out, and then it's contouring, and then now it's starting to go into that pattern. So it's creating, do you know how it's going from each one and it's pattern over, and then it's coming back and doing the finishing as well, and you can see how it's going through the circular patterns. All right, so I'm just going to close that just now, just stop it and close. So another thing I just wanted to quickly go over, I've just gone to this basic one, and it's actually the producing of your post-processing, your code. So if you want to produce the code after your setup, up in the actions, you've got post-process. You've got some configurations that Autodesk provide for you in your local folder. So you've got some templates. You've also got different types of post-processing you can pick, whether it's milling, turning, what type of machining that you're actually doing, and when you pick from that list, it will manipulate what's in this list. So you can see in this list here, there's a heap of different machines lots of different machines in here. Some of them might be familiar to you. You've got some Haas and you've got some Siemens ones down at the bottom as well. So you've got lots of different ones. You've got an output folder where you can output your NC code. You can manipulate the name and the numbering scheme of your NC code. Probably one of the very good things about this dialog box is this link at the very bottom here. So I'm going to click on it. This link actually takes you to a website that Autodesk have created that will allow you to build, and they will help you build post-processors, for any common CNC machines or controls that you've got. So if you're planning on moving forward with Fusion CAM, please come to this website and have a look at what Autodesk provide already. Also, Autodesk are here to support you as well as much as they can, and you'll find that when you click on support, you go directly to their forum. And let's be honest with you guys, the majority of the time someone's done it before you. So if you can't find it, you can also contact Autodesk and they will help you. But the majority of the people in the forums have tried or are in the process of trying something. So please feel free to come here. This is the hub of where to find post-processing information. So once you've picked the machine that you want and all the information that you want, you can post it out. And if we post this out and save it into that location, it opens up a piece of software in the background called brackets. And then this allows you to digest all of the different types of code. So you'll see at the top here the tools that have been used during the setup. So you'll see my chamfer mill, spot drill, and my drill. And then each of these are segmented into the different features. Okay, so the codes will look different, obviously, depending on what type of machine you've picked during the process of churning out that code. All right, so it's fairly straightforward to do that. If you've got any questions, you can fire them through to myself. You can also contact Autodesk. Like I say, they've got a very good support system when it comes to Fusion CAM and HSM. If anyone's using HSM just now and wondering whether they should come over to Fusion CAM or not, if you're a newbie, please be confident enough to give it a go. Again, asking questions of us, asking questions from Autodesk. Challenge yourself to use it because it's there and it's within the collection. And I'm going to be honest with you, Fusion's growing, it's getting better, it's getting bigger. If I just move over to, let's just go back to my presentation, just to show you this. So this is basically Fusion extensions. This has been added in to Fusion 360 in the last couple of weeks. It's tools that are basically, as far as I'm aware from Autodesk, it's advanced features that are coming over from things like PowerMill and the other packages that Autodesk provide that are not in the product design and manufacturing collection, but they are giving you access to use these extensions when you buy cloud credits. So again, if anyone's at the stage where you're producing or looking to produce more advanced features within Fusion CAM, this is a start off point. It's going to grow, it's going to get better, it's going to get bigger. All right, so I'm going to stop talking because I've just talked non-stop for 40 odd minutes. Thanks very much again, guys, for spending your Friday morning, some of your Friday morning with me. Like I say in the past, feel free to email us if you've got any questions about Fusion 360. We're going to keep moving with it. We're hoping that you are going to pick it up and start using it soon. It's not going away and it's getting much better. So what I'm going to do is I'm going to leave the session open for the next 5-10 minutes, and I'm going to leave you with a nice wee video. And if you've got any questions, you can fire them into the questions on the chat. Or if you've got my email address, you can email me directly, or you can contact us via our website. All right, thanks very much, guys.